Hey everyone, happy Monday, day 2 of factoring via the Xbox method. So go ahead and get your stuff. You need your iPad to take notes on OneNote or in a different app or paper and pencil. You need your factor chart that's coming in handy dandy for us. And if needed, go ahead and get a calculator. Please remember that with any video lessons that I post, it is a requirement for you to turn in the notes from the video. Number 1, to serve as something to look back at if you forget or are having a little bit of a brain fart what we did. And number 2, also to hold us accountable for our learning, get in those reps, get in that practice. So these notes from this lesson are going to be due before the bell rings for today's class period to be over, and you will have until 11:59 p.m. to get them in. If you somehow didn't work hard enough, maybe there was some technology going on, right? You have until 11:59 to turn it in for late credit. It will lock after that. So go ahead and let's hop into it. Remember, with videos, you can pause, rewind, fast forward, slow down, or speed up my voice. So go ahead and do whatever floats your boat, whatever works best for you. But I want to make sure we hop in to today's practice. So, per usual, you've got the factor charts, which just list out all of the factor pairs for numbers 1 through 100 for your reference. You have this on a bright pink or a bright orange piece of paper, but I'm always going to provide it to you digitally too, just in case. And it's kind of nice for me to refer back to throughout the videos as well. And when I left you on Friday, you had 2 problems to complete on your own in your notes. It was this problem, x squared minus 8x plus 15, and this problem, 6x squared plus 15x plus 6. As I was going through these, I was like, ooh, those might have unintentionally caused some hiccups, so I wanted to start with them as our warm-up today. And it also brought up a lot of really good moments to clarify. So I'm going to start here. You do not need your notes from Friday. These are in your notes for today. So let's get it started and let's see if you were able to successfully factor x squared minus 8x plus 15 using, the best of your knowledge, the Xbox method. Okay, first things first, we want to determine if a is negative. So looking at our equation, a would be over here. It is not, so we can move on. The next question is there a greatest common factor between x squared, 8x, and 15? X squared, that's like 1x squared. If I'm looking for the numbers, 1, that's just 1 times 1. 8, that's 1 times 8. 2 times 4. 3 doesn't go into there. 15, that's 1 times 15. 3 times 5. Yeah, there's no GCF. If anything, it's just 1, right? The values that they have in common. So that 1 isn't very exciting. It's not even that large of a number, so we're going to leave that behind. But the next thing that we're ready to do is to identify A, B, and C. A is 1, B is negative 8, and C is 15. In order to use the x, I need to multiply a and c and put that at the top. This means I'm looking for I'm looking for 2 numbers that multiply to 15 but add up to negative 8. So again, 2 numbers that multiply to 15 but add up to negative 8. So again, I kind of wrote the factors of 15 already. 1 and 15, 3 and 5. And you might be thinking, well, I need positive 15. 1 and 15 and 3 and 5 are not going to cut it for me. 3 and 5 are really close, but that's positive 8, not negative 8, right? However, remember that a negative times a negative is a positive value, and negative 3 plus negative 5 does give us negative 8. So that's like kind of the first hurdle that might have been a little troublesome for you. But that fact that a negative times a negative is a positive actually comes up when we go to use the box part of the X box method, okay? To fill in the X box, we always start with the first part of our equation, x squared, and the last part of our equation, 15, and we put those in the first and the last spots in our box. And then the -3 and the -5 go in the other spaces, and they came from the x, so we're going to put x with them. Now that we have this filled in, we're ready to factor out the greatest common factor vertically and horizontally. X squared and -3x, those have an x in common. That is the greatest thing they have in common. -5x and 15, the greatest number they have in common is 5. X squared and -5x, they have the greatest common factor of x in common. And -3x times 15, those share 3. Okay, per usual, it's extremely important that we always check our work. You do not want to not check, just being quick with things, because you might have made a mistake or there might be something that's a little bit sneaky that you have to check. So x times x is in fact x squared. So far, so good. But x times 5 is 5x, not -5x. So we actually have our first error. And it's a little sneakier than you think. So we'll hold off. Let's check the rest of our work. 3 times x is 3x, not negative. So again, another mistake. But 3 times 5 is 15. So something's going on with -3x and -5x. It's not quite matching up, right? It's kind of weird. Now, we want it to work, and if we had like -5 and -3, it would work out, right? We'd get the negative over here and the negative right here. So this is really a big reason why we want to check our work. Because remember, we did have -3 and -5. -3 times -5 is positive 15, right? So it didn't look at first like when we were pulling out our greatest common factors, it did not seem that that our greatest common factor was going to be -5, right? It didn't look like that at first. But remember, -5x, that's like -5 times x. And 15, I could have written as -5 times -3, right? So now if I'm looking, oh yeah, they share -5 in common, so I can take out that -5. So that was kind of unintentionally sneaky, right? And the same story goes with -3x times 15, right? Now that we're looking at it, now that we wrote 15 as -5 times -3, if I'm looking to find the greatest common factor this way now, between -3x and -5 times -3, you're like, wait a minute, yeah, they share -3 and -3, so that's why this guy should be negative. So I didn't mean to trick you on this, but it's definitely a very good idea to check your work when you're using the box method to see if it's correct, because you might find this type of situation where you need 2 negative values to help you out. And a hint is that the fact that there's negatives inside these boxes too. So you could kind of use that as a rule of thumb. So again, let's check our work now. X times x, x squared. X times -5 is -5x. -3 times x is -3x. And -3 times -5 is positive 15. Whew. Glad we got that handled. Last thing to do on this problem is to rewrite our equation in factored form. Remember, factors are just numbers that multiply together, right? Parentheses mean multiply. You have x minus 3 and x minus 5. This is equivalent to x squared minus 8x plus 15 in factored form. Cool. Let's do the next one as well. This one I also left you with on Friday to try and complete on your own. I'm not going to be looking that it's necessarily correct, but that you tried it. Because remember, sometimes we get things right when we're learning. Sometimes we make mistakes. But when we make mistakes, that's when we learn the most from them. And this one also had a little bit of tricky stuff too, because we've got to make sure that we're using all of the boxes to help us check our understanding, right? Our goal right now is to factor 6x squared plus 15x plus 6. So question number 1, is A negative? I'm looking over here. No, it's not. Is there a greatest common factor though? It doesn't look like it at first, but there is actually. Remember, 6 is 1 times 6 or 2 times 3. 15 is 1 times 15, 3 times 5. And 6 again is 1 times 6 and 2 times 3. So again, they do have something in common between all of the numbers. The greatest common factor is going to be 3. So it's really important that we factor our greatest common factor out of our equation. And since we did that, what's left over is this 2. So that's 2x squared. This 5, that's plus 5x in the middle. And then plus 2. Right, so we're really trying to factor 2x squared plus 5x plus 2. And so A from this situation is 2, B from this situation is 5, and C from this situation is 2. Really important that we use that. Otherwise, when you go to check your box, you'll be like, what the heck is going on? Now we're ready to set up our x. X is going to be A times C, or 2 times 2, which is 4. So I'm looking for 2 numbers that multiply to 4, but add up to 5. And thank goodness, this is so nice. What happens when you factor out the greatest common factor is it makes the numbers smaller and a lot easier to figure out the x in the box. So 4 times 1 is 4, and 4 plus 1 is 5. So those must be my factors. Now I'm ready to start filling in my box. I'm going to start with 2x squared, that starting value of my polynomial that I'm trying to factor. And the end is going to go in the last box. From my x, I know that I've got 4x here and 1x here. Now again, if you didn't factor out the greatest common factor, this part right here, when you're going to find the GCF and check your work, you'll notice that there's a mistake, and it's all because of the greatest common factor. Now I'm ready to see 2x squared and 4x. They definitely share an x, and they also share the biggest value of 2. 1x and 2, they don't have really anything in common, so I'm going to give them just a 1. Technically, they still have 1 in common. 2x squared and 1x. They share an x in common. That's the greatest thing they have in common. And 4x and 2, the greatest thing that they have in common is 2. Now we're ready to check our work. X times 2x, that is 2x squared. 1x times 1, that's 1x. 2 times 2x, that's 4. 2 times 1, that's 2. Yay! Now we're ready to write it in factored form. Remember, I just erased it, but how they all had 3 in common. That was the greatest thing in common. Don't forget it. Remember, we had 3, 2x squared plus 5x plus 2, and we currently just use the x box to factor this thing. So the 3 is still here, and what we just factored was 2x squared plus 5x plus 2. That was A, B, and C. So that means I have x plus 2 from the left side. If it's positive, we just put a plus. and then 2x plus 1. All three of these forms are equivalent. However, the best form that we want to use and our final answer is going to be this. When we get to solving quadratics, you'll see why we want it in our smallest, greatest common factor factored equation. It just makes our lives so much happier and so much easier. Okay, I've got 2 more examples. I just figured I want today to be a little bit more guided practice and tomorrow to be a little bit more independent practice. So I just want to make sure we're good. Like, no tricks. Do we know how to factor this using the X box? So I just put 2 more examples together and then a couple challenge problems to see if we can elevate our learning experience. So 2x squared plus 13x minus 7. This is what I want to factor. Again, use this chart to guide your thinking. There is power in repetitive reasoning and pattern recognition, and we're trying to activate that so that we can think critically about our problem solving. First things first, is A negative? Looking right here at 2, no, it's not. Is there a greatest common factor between 2, 13, and negative 7? So 2, that's just 1 times 2. 13, that's 1 times 13. And 7, that's 1 times 7, right? The only thing they have in common is 1. So we can see the GCF is 1, but we don't need to take that out of the equation. So it's not really helpful. It just leaves 2, 13, and 7 behind. So it's not very exciting for factoring purposes. That means A is 2, B is 13, and C is negative 7. Now I'm ready to set up my X box. The top is 2 times negative 7. That's negative 14. So I'm trying to come up with 2 numbers that multiply to negative 14, but they add up to 13. That means I'm probably going to use 14 times 1. And I need it to be positive 13. So 14 take away 1. That gives me positive 13. And 14 times negative 1 is negative 14. Amazing. Now I'm ready to fill in my box. Remember, start with our starting part of the equation, 2x squared. End the box with what we ended our equation with. And 14 is going to go inside the box. It really doesn't matter where. I've just been always putting them from left to right. And negative 1 inside the box with an X. Now that we're here, we're ready to take out our greatest common factors. So 2x squared and 14x. They both have 2 in common, and that's the biggest thing they have in common. So we'll take out 2, and they both also have x. The next part, negative 1x and negative 7, they actually both share a negative. So I'm going to take out that negative 1. Kind of learned our lesson from the other one before. And actually, they both have negatives. Then I want to take out the greatest common factor of 2x squared and negative 1x. They definitely share 1 and an x. And lastly, but not least, 14x minus 7. 14 and 7 share a greatest common factor of 7. Let's check our work and make sure it's true before I write my final answer. 1x times 2x is 2x squared, right? 1 times negative 1x is negative 1x. 7 times 2x is 14x. 7 times negative 1, negative 7. Always make sure you can check it out first before you finally write your answer in factored form. It would be x plus 7 times 2x minus 1. Remember, if there's nothing in front of it, like this 7, it's positive, so put a plus. Boom. X plus 7 and 2x minus 1 is the same as 2x squared plus 13x minus 7 just factored. Okay, I hope we're getting a little more confident. I know the first two maybe might have shook you up a bit, but let's see if we can do one more. No tricks, just straight up, can I use Xbox method, right? So I want to factor 5x squared minus 4x minus 9, okay? Let's use our questions. Is A negative? No, it's not. Do they have a greatest common factor? If you need to, please make the list. Once you get a ton of practice, you'll feel a lot more confident in it. But if you need to make this list consistently for a couple times, hey, you're going to consistently get the answer correct or be 100% sure. Looking at this, really the only thing that they have in common is 1. Like we said last time, not much to write home about. A would still be 5, B would still be 4, negative 4, and C would still be negative 9. So we'll leave that. We're ready to fill in our box. It's going to be the first times the last. 5 times negative 9, 9, 18, 27, 36, negative 45. So I need two numbers that multiply to give me negative 45, but adds up to negative 4. This is definitely going to require your factor chart. 45 has 1 and 45, 3 and 15, and 5 and 9. I'm definitely going to have to use like 5 and 9. They're closest together. And you might notice that 5 is exactly 4 spaces away from 9. That's kind of the trick. If you're using the factor chart and the number on the bottom, that's how many spaces you want each number to be away from each other, right? And then I need it to be a negative product. 5 times 9 right now is positive. I need it to be negative, which means one of these numbers, 5 and 9, needs to be negative. And if I want a negative answer, when I add them, the bigger number needs to be negative. Now I'm ready to fill in my box. It's going to be starting with 5x squared, ending with negative 9, and I'll fill in the others. Ooh, this has nice GCFs. Looking right here, they share a 5, they share an x. Looking right here, they share minus 9. Ooh, this is so nice. That is satisfying. Left to right, 5x squared, negative 9x, they share an x. 5x minus 9, they share 1. The greatest common factor, I should say, is 1. Let's check our work. X times 5x is 5x squared. X times negative 9 is negative 9x. 1 times 5x, that is 5x. 1 times negative 9, that is negative 9. Yay! Now we're ready to write it in factored form. X1, it's a positive 1, so let's put a plus sign. 5x minus 9. Voila! X plus 1 times 5x minus 9 is 5x squared minus 4x minus 9 in factored form. I hope you're starting to feel a little bit more confident now. And really, this is what I want us to just practice and start to feel good about. But before we do, I have one more challenge example. Well, one more type of problem. And there's actually 2 of them. And this is called a difference of squares. This was one of the problems that I did not require you to do last week. I told you we would catch up on it today. And it feels different because it doesn't have anything in the middle. But that's okay. The Xbox still works. So let's try and factor x squared minus 16 and use our Xbox method. So first question, is A negative? No. Is there something in common? Also no. A is 1. C is negative 16, but there is nothing in the middle. which means b is nothing. And a good number for nothing is 0. Then we're going to do 1 times negative 16. So I got negative 16, but I need it to add up to 0. So I need two numbers that multiply and give me negative 16, but they add up to 0. So if I'm looking at my factor chart for 16, right? If I'm looking at my factor chart for 16, I have 1 and 16. I've got 2 and 8, and I've got 4 times 4. And remember, I need it to be negative 16, so it's either this situation or 1 times negative 16, 2 times negative 8, 4 times negative 4, right? Those are the options I have, really. But check it out. 4 and negative 4. That adds up to 0 right away. That's like either of these. I guess the order doesn't really matter. Nice. So I can still use Xbox. Don't worry. Everything is all good. I've got this going for me, so I can start filling in my Xbox. It started off with x squared. It ended with minus 16. We've got a 4 and negative 4 and tack on an x. And now we're ready to factor out the greatest common factor. X squared and 4x both share the greatest value of x. The greatest common factor between negative 4 and negative 16 is negative 4. The greatest, and the more you use your charts, guys, the better you're going to get at factoring out the greatest common factor. X squared and negative 4x, they both have x in common, the greatest value that they both share. And 4x minus 16, the greatest thing they have in common is 4. Always, always, always take the 5 to 10 seconds to check your work. I promise you, you're going to feel so much better. It's extremely satisfying, and you'll know that you got this correct. X times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. 4 times negative 4 is negative 16. All right. So that means my factors are x plus 4, because that was a positive 4, and x minus 4. What? That actually seemed like less of a challenge than regular, right? That didn't seem that crazy. Pretty nice, right? Okay, I have something similar too, but the reason this is called a difference of squares, right? Difference because there's a minus sign, and then x squared is something we like to call like a perfect square, right? And what I mean by that is it's like x times itself, right? That's x squared. And 16 is the same too, because it's 4 times 4, right? Notice that those were the values that we used in the x, positive 4 and negative 4, right? So a difference of squares is like a perfect square minus a perfect square, something that's multiplied by itself. And those are actually really fun to factor. Now here's another difference of squares, 3x squared minus 75. And we're going to follow the same process, right? So is A negative? No. But is there a GCF? We better check. So if we're going to factor 3, that's 1 times 3. And if we're going to factor out 75, it's going to be 1 times 75, 3 times 25, and 5 times 15. Doing this, we can see like, oh yeah, they definitely share 3 in common. So remember, we're going to factor out a 3 straight away. That means we have 1 x squared left over. And since we're using that, we also have 25 minus 25. All right. A is 1, B is 0, C is negative 25, and we're ready to move into the box. 1 times negative 25 is negative 25. B is 0, so I'm looking for two numbers that multiply to give me negative 25 and add up to 0. You might have remembered from the last examples they're called a difference of squares because it's the same number multiplied by itself. 5 times 5 is 25. Make one of them negative. You got 5 times negative 5 is negative 25. Precisely what we wanted, and if you add them, they add up to 0. Remember, it's really important that we're adding 1x squared and negative 25 into this box because we factored out 3, not 3x squared and 75. Then we're just going to plug in 5x and minus 5x. GCF, we're on our way. 1x squared and 5x shares x in common as the greatest thing. Negative 5x and negative 25 has a GCF of minus 5. 1x squared and negative 5x, that shares an x in common. 5x squared minus 25 shares a 5 in common. Always double check your work. X times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. 5 times negative 5, negative 25. So I officially can rewrite my factored form as 3, that was my GCF, times what I have outside of my box. X, positive 5, let's put that plus sign. X, negative 5, boom. This is the lowest factored form of 3x squared minus 75, but this other one is also still valid. Again, it's not that they're wrong, but when it comes to solving, this is where we want to be. That is the best. So that's a good chunk of practice today. I've also given you some delta math, DM16. This is not due until Tuesday. It's Monday right now. So it's not due until tomorrow. And you're going to have class time on Tuesday to complete it, okay? The thing about delta math is it's just your computer. So I highly, highly, highly recommend you pull back up these notes when you're working on your delta today and tomorrow. And you just scroll and you create your own X box. Use the prompts on the screen, right, to help you. And you're going to find it so much easier if you write out these steps repeatedly when you're trying to factor your quadratic functions. So that's all I have for you today. Don't forget to turn in your notes onto Canvas, and you can get started with delta because you'll probably need today and tomorrow class time to finish your delta math. But tomorrow, that's all I have planned for you is just delta math. Okay? I hope you're feeling better about factoring. Give yourself a little reflection. Like, do you feel like we've met our learning goal? That you know how to factor quadratic expressions using the Xbox method? By the time you're done with your practice tomorrow, you should feel pretty good about it. All right, guys. Thanks so much. See you next time.